Okay, so today is 11.5 area of similar polygons. So here is your foldable. So it's just like yesterday's, you fold right here up to that line, and then you fold this part, okay? So hopefully this one will turn out better than yesterday. You can see it. So we need to figure out what's the theorem for the area of a similar polygon. So that is if two polygons are similar, with the lengths of corresponding, and remember that corresponding is they're in the same spot but on different polygons. So corresponding sides in the same ratio A to B. So remember, it can be A colon B, A over B. It could literally say A to B. Then the ratio of the area, or of their area, is going to be A squared to B squared. Okay? Everyone have that? Okay, remember, I'm on video. So if I'm going too fast, you can rewind me, or you can stop, pause, do whatever. But make sure you play it all the way through. Remember, you do have a test on Thursday. Okay, so looking at this, the side length of polygon 1 over the side length of polygon 2. So polygon 1, that side length is A, and then polygon 2 is B. I'm going to change my colors. So it's going to be A over B. I'm trying to make sure this looks better, so I'm holding it with one hand. So if you're looking at the area, remember you just square. So it's going to be A squared over B squared. And then that's it. Okay, let's go ahead and look at some problems. So let's look at example 1. Example 1 is triangle ABC is similar to triangle XYZ. So I'm trying to find the ratios of the area. Okay, so ratio of the sides. So this is the first one, this is the second one. So the ratio of the sides is going to be 5 to 8. So I'm going to go ahead and write that down. So the ratio of the sides is going to be 5 over 8. So if I'm trying to find the area, then I just square those two, right? So I'm going to write this down here. The ratio, that's ratio. Heather, that's ratio. I'm just letting you know. Ratio areas is going to be 5 squared over 8 squared. And you should know 5 squared is 25, 8 squared is 64. So 25 over 64. And literally, that's it. Okay? That is all you do. Once again, you can pause if I'm going too fast. Let's look at example 2. So example 2, polygon ABD is similar to polygon MNOP. The sides we have, or this time we actually have the area, is 28 and we have 63. So we need to find the ratio of the side lengths. So we're starting with the area. So I'm trying to figure out how to write. And hold this at the same time. So we have area is 28 over 63. Okay, so can these be reduced? What number can reduce both of them? Think, what number can go into both? 7, in case you were wondering. So I'm going to divide by 7 on both. So how many times can 7 go into 28? It's going to be 4. And 7 goes into 63, 9 times. Okay, remember, because those are squared, you're going to have to square root those numbers. So the square root of 4 and the square root of 9. And square root of 4 is 2. Square root of 9 is 3. So that's your answer. Okay, so far so good? You got 2 more problems. Yeah. Okay, example 3. On example 3, we got polygon ABCD is similar to PQRS. We have the side 12 and 15. We have the area for one of them, which is 325. So I need to find the area of ABCD. So the first thing I need to do is do the ratio sides. So I'm going to go ahead and write down here. Ratio sides. Ratio. Okay, once again, Heather or Yasha is probably making fun of me because I messed up. Okay, so I got 12 and I got 15. So that's my ratio. 12 to 15. Make sure, can it be reduced? What goes in the both numbers? That's right, 3. So you will have 4 over 5. That's going to be my ratio sides. So remember, I need to find my ratio area, and all I got to do is square both numbers. So ratio area, and that's going to be 4 squared over 5 squared. 4 squared, you should know, is 16 over 25, because 5 squared is, once again, 25. So remember that formula that we used when you know the sides and then you're trying to find the area? So that's what we're going to end up doing. So I'm going to have 16 over 25 equals, now we don't know the area. Look at this. We don't know the area of the small one. So we're going to put an X. We do know the bigger one, which is 325. So I'm going to write that down. This is our proportion. Okay. So I'm going to cross multiply. So 25 times x, it's going to be 25x. 16 times 3, 25. Yes, make sure you use the calculator. It should be 5,200. Even though I'm giving you the answers, you should put it in your calculator. Make sure you know how to get the answer. Then I'm going to divide by 25. And when I do, x should equal 208. And remember, because this is a area, it needs to be centimeters squared. Okay, so that was number 3. We have one more problem. So in number 4, we have example 4, ABCDE is similar to JKLMN. And once again, we have a side. So we have 27 and we have 8. I'm sorry, we have 27. We don't know a side here. We have the areas on this side, 162, and we have the area on this one, which is 8. Okay, I need to find, now there's a typo on this. I need to find LM. So I'm going to cross that out and put LM. In case you're wondering, no, I did not make this. So once again, I need to find the ratio areas. So the ratio areas, what they gave me, 162 over 8. So I need to figure out, can I reduce this? When in doubt, divide by 2. So divide by 2. That's actually going to be 81 and 4. Okay, so it has been squared. So I'm going to write that. Has been squared. Okay, which means the ratio sides, if I square root that, would be what? What's the square root of 81? Have my inner Dora coming out. Square root of 81 is 9. Square root of 4 is 2. You did it. Hooray. Okay, I'll stop. So we're setting up the ratio. 9 over 2 equals, we have the side for the top one, so it's 27. We don't know the one for the bottom, so it's going to be x. So once again, I'm going to cross multiply. I have 9x times 27 times 2, which is 54. All I got to do, divide by 9. X is going to be equal to 6 inches. Okay? And there you have it. That's the notes for today. These will be on Google Classroom. And your homework for today is numbers 1 through 7. Okay? See you later.